Hello everyone. Let's discuss the solubility of solid in liquid in this particular module of the chapter Solutions and Colligative Property. Let us talk about solubility in terms of four important parameters, of which first I'll discuss something like this. If you take a solid solute and if it is added to a solvent, say for example it is water, then what I observe is the concentration of the dissolved solute keeps on increasing, and this process is called as dissolution. Now, the second observation is that when this concentration of dissolved solute increases, what happens is this dissolved solute, they start colloiding with each other, and when they start colloiding with each other, they will have a tendency to get separated out where in the solution, and that is called as crystallization. Now, in a solution, a state will be there when the number of solute which is going in the solution will be exactly equal to that of the number of solute which is getting separated out from the solution, and that is called as a state of dynamic equilibrium. And at a state of dynamic equilibrium, I can say that the concentration of solution remains constant. Rather, it means that no more solute can be dissolved at this temperature and pressure, and that is called as a saturated solution. Now, apart from saturated solution, you should also know what is unsaturated and what is supersaturated, which I'll take just after this topic. So I was talking about the four important terms, that is dissolution, crystallization, state of dynamic equilibrium and saturated solution. So now you can easily talk about the solubility. It states that it's a maximum amount of solute that dissolved completely in a given amount of solvent at a constant temperature is called the solubility of the solute in a given solvent at that particular temperature, and that's the definition of solubility. Now, since we are talking about solubility, let's try to understand that it is expressed as the grams of solute per 100 centimeter cube of the solvent at a 25 degrees Celsius or at a very specific temperature, and its units are mole dm cube inverse or mole per dm cube. And the most important factor that solubility is affected by temperature, rather it changes with temperature. As I spoke about some important terms like unsaturated and supersaturated, let's have a look at this. When I talk about unsaturated, it simply means that here the amount of solute present is less as compared to required to form a saturated solution. In this case, the equilibrium between the dissolution and crystallization does not exist, and this solution can accommodate more amount of solute till it becomes saturated. That's all about unsaturated. Now let's learn about supersaturated solutions. In case of supersaturated solutions, here there is an excess amount of solute as compared to that required for forming a saturated solution. And here I can say that here this particular solution cannot accommodate more amount of solute, and that's a super saturated solution. Let's have a look at the factors affecting solubility in this type. There are three factors: nature of solute and solvent, temperature and pressure. In case of nature, I can say that like dissolves like phenomena. Polar solute dissolves in polar solvent and non-polar solute dissolves in non-polar solvent. With respect to temperature, as temperature increases, the solubility also increases and pressure has no significant effect. Let's have a look at the effect of temperature on solubility. Now, when I say effect of temperature on solubility, I can say that generally solubility is going to increase with increase in temperature. The reason is very important. It is due to the expansion of the empty spaces which is there in the liquid solvent. Rather, with every increase, that is 10 degree rise in temperature, you will see that increase in the solubility is by two folds. It increases double. Perfect. And I also say that the process of solubility can be exothermic or it can be endothermic. And let's see a variation of solubility of some ionic solids with temperature. If you see the graph of solubility versus temperature, then I take three examples over here like NaBr, KCl, NaCl. The solubility increases gradually, or the increase in the solubility is very less as compared to that of the increase of temperature. But in the other three example, if you see over here, the increase is quite big with respect to temperature, and the examples are KNO3, NaNO3 and KBr. Whereas if you see a sudden change over here in case of Ne2SO4, which is just going to come with the increase in temperature, the solubility increases, and with the further increase in temperature, the solubility decreases. That's an exceptional behavior of Ne2SO4. So these are the 7 examples which shows the variation of solubility, correct, with respect to temperature. That's all we have for this particular module. Thank you so much.